Okay. So this is an application of the first type of differential equation that we did. So this will be a nice little review for you. So what does orthogonal means? Anybody know?
No.
So no one has a clue what orthogonal means. That's fine. I just was seeing if anybody knew.
Maybe it means the thing that involves, right angles.
Did you just read that off the page?
No.
So orthogonal means 90 degrees or perpendicular. So the whole point of this application is to take a function and to find a function that is orthogonal or 90 degrees to it. So where they meet at a 90-degree angle. So there's an example given right here in the picture. It shows parabolas, and the other function is an ellipse. So when those functions cross, they cross at 90-degree angles. So here we've got an exponential, and we want to know what is orthogonal to that function. So the first thing we need to do is find the derivative. So we need dy dx. So that's going to be minus k e to the minus x, right? Now, why did we want that? Well, if these two functions are to be orthogonal, well, that means that their slopes must also be orthogonal. Right, for two functions to be, or at least if you remember back when you studied lines, for two lines to be perpendicular to one another, they had to have opposite reciprocal slopes. So that's exactly what we're going to do here. So here's our slope. We need to find the opposite reciprocal. So to do that, we're going to flip what we've found here, right? We would do 1 over. And to make it opposite, we just take negative of the whole thing. Well, it was already negative, so it becomes positive. And this is now what we call dy dx. If you want, maybe you could call it dy1, dy2, so you know that the first one's from the original function, and the second is for the new function. Now, before you solve this, you got to come back over here and solve for this constant k, and then plug it in there. So this equation here, solve for k, would be y over e to the minus x. Or if you want, y e to the x, right? So I come back over to my derivative, or my slope, and I plug that in. And that's nice because e to the x times e to the minus x is e to the 0 or 1. And so now I've got dy dx equals 1 over y. So now I have generated a differential equation that is separable and is easy to solve for the function. So I would just move the y to the left-hand side and move the dx to the right-hand side. And then I can integrate. So that's y squared over 2. And this is just x plus c. And to finish up, we move the 2 over and take a square root. And I'm going to write it like that. So it shows that the square root function should be orthogonal to those negative exponentials. So let me go through the method one more time. First thing I did was I took the derivative dy dx. I need the orthogonal trajectory or the opposite reciprocal slope. I think it's Rocall, I think. That's how you spell it. So to do that, we just do 1 over the function, and then the opposite is just take the negative of it. So it made it positive. You set that equal to dy dx for the function you're trying to find. Excuse me. If there is a variable, or sorry, a constant like k, well, I guess it's technically a variable in this case, once you solve for it, then you have to solve for that and plug it back in before you carry out the integration. And then once you do that, you find your function that is orthogonal.
So does it matter what format the equation is in when we start? So like the first one that we just did started with y equals, but I'm looking at the next one and it's not in that format.
So recall in Calc 1, you should have done something that was called implicit differentiation. Do you recall that at all?
Like vaguely, yeah.
So you don't have to have y equals in order to differentiate that function, right?
Yeah, okay.
If you do it implicitly. And that actually makes this one really nice because you got a constant on the other side. So when you take the derivative of it, it goes to 0.
I
So
have a like algebra question for the top. Like you took it and it was negative k, and then there was like the negative power, but when it went under the fraction bar, the negative power stayed negative. So why?
so this was the opposite reciprocal.
Okay,
That means whatever this is, do 1 over it.
right.
Then take and multiply the whole thing by -1.
Oh, okay.
So I didn't I didn't flip the fraction or try to move the e. I just did the reciprocal of it.
Okay. All right. Thank you.
You're welcome. All right, so the second one, if I differentiate the whole thing using implicit differentiation, I get 2x minus 2y dy dx. And on the other side is a constant, so I get 0. So recall implicit, you take the derivative of y as though it's a function of x. So you would do it just like any other variable. So we get 2y, but then you need a dy dx to come out of that. So first I need to solve this for dy dx. So I moved the negative, or moved the 2x over and made it negative, but both are negative, so we can make them both positive. If I were to divide through by 2, the 2's would cancel. And then finally, I want dy dx by itself. So it looks like it's going to equal, oops, x over, come on, over y. Now that's for my first function. I need the opposite reciprocal. So opposite would be negative, and the reciprocal there would be y over x. And now I'm setting that equal to dy dx. So I'll put OR there for opposite reciprocal. Now I need to solve this separable differential equation. So I'm going to move the dx to this side, and I'm going to move the y to that side. I'm going to leave the negative on the left. So that would be negative dx over x equals dy over y. Then I can integrate both sides. I'm going to go ahead and take this negative up on the x there, because I know I'm going to take e of both sides. Easily the e and the log on the right cancel, and I'm left with just y. On the left, I have e to the natural log of x to the minus 1 times e to the c. So e to the c, I'm going to call c1. And e to the log cancel. You have x to the minus 1, which is the same thing as just 1 over. So this tells us that originally we had some kind of square root function that we would have had for y. Looks like it's orthogonal to these. Well, actually, I guess this is a family of. No, I guess it isn't circles because it's minus. Yeah, so some kind of square root function is orthogonal to this 1 over x or some constant over x.
Okay, I have a question really quick. And I encountered this when I was like doing my exam review too. So you know how we like where you add in the e's and stuff. So it turns into the e to the ln x and the e to the c like multiplied because you raised that whole term, right? So then you just split it up and it's the same as e to both of those powers multiplied, right?
Yeah, so e to the a plus b is the same thing as e to the a times
Okay.
e to the b.
Okay, and that's why when you turn the EC into one constant, it stays multiplied.
Yes.
Okay. All right, cool.
So any questions about that particular application?
There's a question in the chat.
I I think they answered their own question if I read it correctly. So that was the last application that I wanted to do. I'm not going to worry about the mixing problem. So if you like, I'm going to pause recording for a moment. All right, share the review. So compute the arc length here. All right, so first we need y prime, right? Which would look like that. Do you agree?
Yes.
Okay. And we're just doing arc length. So that's an integral from 1 to 2 square root 1 plus f prime. Quantity squared, right?
Yeah.
So let's see. Before I do that, do I want to put these together and see what this is going to look like? That would be 16x squared. That, right? Don't really want to do that. I think I'll just leave it alone and see what happens. Just 1 plus, and then we're going to get 4x squared. Then the middle term would be, let's see, minus 1/2, right? Because it'd be 2x times 1 over 8x times 2. So that's 4 over 8, 1/2. And then finally, this. And then you add the 1 and the 1/2, or the minus 1/2, and you get a positive 1/2, right?
Now, now for the factoring, wouldn't the negative 1/2, won't there be x next to it? So it'd be 1/2 x.
Well, you multiply these two terms together, right? And one has an x in the numerator, one has an x in the denominator.
Oh, okay. So it cancels out. I gotcha.
Yeah. And this looks just like what we had before, but with a plus 1/2. So it must factor as the exact same thing, but with a plus sign, right? And then the square root of something squared is that something. And then integrate it. Right, the first one you get x squared over 2, those cancel. The other one is over x, so that's natural log. And let's see, you get 4 plus 1/8 natural log 2 minus 1 minus 1, oops, minus 1/8 natural log of 1, but that's 0. And 4 minus 1, just going to give us 3. So to me, it looks like the answer is 3 plus 1/8 natural log 2.
Wait, can you scroll up for a sec? So how did you get to 16x squared minus 1 over 8x?
I just was looking to see if I would benefit if I put them together. I never actually used that in the problem.
Okay. That makes sense. You just cross multiplied them.
Yeah, I wanted to see if it would turn out to be something that looked better, that would make the problem easier for me, and after doing it, didn't seem like it would do much.
All right, thank you. I was just confused why that was there, but that clarifies it.
What's there?
I had a question about that rule. I know you mentioned it earlier, how if you have 1 plus like a minus b squared, then that becomes a plus b squared. Does that work the other way around if it's like a1 plus a plus b squared?
Well, it doesn't. It only works because of the format, right? This has an x and this has a 1 over x. So the two terms have to have the same number of x's,
Okay,
and one has to be in the numerator, one has to be in the denominator.
that makes sense. Thank you.
Mm-hmm. Any other questions about that one?
So, oh, I actually got one. So say on the test, since there's not going to be any numbers, which I assume there's not going to be any set bounds, wouldn't it just be
No, there's bounds. They're just not numbers. They're like A to B or something like that.
okay? I got you.
So
What was
does that
the-
mean, just real quick, so that means like it would be all variables, like, so it would be this question if there wasn't an 8, kind of.
Basically, yeah.
Okay, cool.
There's a little more to it than just here's a function. Like, yeah, there is a little bit of thought you have to put into it.
Yeah, that's expected.
But it's not, it's not exactly here's a function with no 8 in it, right? What was the other one you guys wanted me to do? 6, is that right?
Yes.
Okay. So Hemispherical tank. Eight feet in diameter, which means my radius is 4. My density is 70.75 pounds per feet cubed. We're going to assume that it's in ground, right? Because it says pump to ground level. So top of the tank is at ground level. We have a slice in here. Let's define this distance as y. This distance here is the radius of the slice. This distance here is the radius of the sphere. So we need the force, which is the density times the volume of a slice. The volume here would be pi r squared dy, and then of course times rho. So pi rho, little r here, squared, using the Pythagorean theorem, is going to be 16 minus y squared. All right, so if we do the Pythagorean theorem, it's y squared plus r squared equals 16. So just solve for r squared.
Your microphone kind of blew up.
Oh, sorry.
Yeah, no, it's your turn. Caught me off guard.
It tends to do that on this program for some reason. All right, so then the work is the integral of my force. And then we need to do the displacement, which is y for any slice. And that would go from 0 to 4, because the distance from here down to the bottom is just the radius. And the slice at the very top doesn't have to go anywhere. So then just multiply this in and integrate.
All right. Thank you.
Mhm.
For me, I don't need to see you just integrate it, but if someone else does, then you can fully do the problem. But I was confused with the wording of the problem. Like when it said from the tank to ground, like I didn't know if it meant like, I know it was below ground, but I was assuming that it was ground level, but I wasn't 100% sure. That's where I was confused.
Yeah, if it doesn't specifically tell you a distance, then just assume that it's at ground level.
So now,
No, you go.
if it was a certain distance, that y would be y plus the distance, right?
All depends on where you define y. So in this case, yeah, I would define y the same way. And then your displacement, right, this value here would be that number, like the distance down to the tank plus y.
Okay, yeah. Like it was 50 feet, it'd be y plus 50.
Right.
That's my question. So
It's interesting because you both started the question the same way. All right. Any other problems that you would like to see?
um,
One at a time.
I was thinking, could we do 12?
What's 12? I'm not looking at it.
I believe it's orthogonal trajectories of the family. Family curves.
So the
Y.
ones we were just doing.
Mhm.
Someone just asked if I could finish this. Just let me do that really quick.
Sure.
So this would be 16y squared over 2 minus y to the fourth over 4. And of course, there's a pi rho out here. 0 to 4. This would reduce down to an 8. That if I'm not losing it. That number looks kind of small though. So you multiply that by pi. It's like 14,225. That's what I had down here. Yep, 4,528 pi. Yep. And then of course for the last part, you just divide that number by 34.375. So that's not hard. All right, when he asked me to do orthogonal, right?
Number 12, I believe.
So first thing is take the derivative. If we do it implicitly, this is 2y dy dx is equal to 3kx squared, right? Solve that for dy dx. And then come back over here and solve this for k. K is y squared over x cubed. So plug that in. So I'm just breaking this up, right? 3 halves, then there's x squared over y, and then I'm going to plug in k, which is y squared over x cubed. So this turns out to be 3/2. We're going to get a y over x. Now that is the slope for the original function. I need the opposite reciprocal. So I need to solve, when does dy dx equal 2x over 3y, and integrate that. So that gives me 3y dy equals 2x dx.
Wouldn't that be negative if it's the opposite reciprocal? Okay.
Yeah, you didn't see that there?
Um,
Must have been a glitch. All right, so then integrate both sides of that equation. You would get 3y squared over 2 equals minus x squared plus a constant. And if you solve for y, like that. All right, so again, it's take derivative, plug in k if needed, take the opposite reciprocal, and then solve that differential equation.
So I have a quick question. Did you say if Newton's law of cooling will be on the exam or not?
So I think somebody asked if there was going to be an application of differential equations.
Oh, okay, so that, yeah. All right.
But the ocean or static?
Could we do 9A?
Let's see. See if I can get myself some room.
I think I would prefer to do 9B, actually.
Oh no. What am I doing? Which one?
I,
You do B.
Prefer 9B.
I would rather see B.
Okay. So we need double prime, prime, and then the original function. Let's see. So I always remember the quotient rule. It's low d high minus high d low. So there's that.
Yeah. I have a question.
Already?
Yeah. So you're doing the quotient rule, but would it be okay to take the ln x, put it to the side, and turn that into x to the -2?
And use the product rule?
Yeah.
Yeah.
Okay.
You'd probably have to put the two things back together at the end. Or I guess you could just leave them all with negative powers if you wanted.
Okay.
So that's y prime. You could also write it this way. It's probably better. So then I need y double prime. So again, I need to do low, derivative of high, minus high, d low, all over low squared. Simplifying, looks like that. So now I got to plug that all back in. So this is x squared times what I just found, which is 6 natural log x minus 5 all over x to the 4th. Right, okay. Plus 5x times y prime, which was that. Room here. On erase. Okay. And finally, plus 4 times this, right? So everything is over x squared, so we can forget about that for a minute. Then we got 6 log x. This is going to give me minus 10 log x plus 4, right? So 6 minus 10 plus 4 all times natural log x. There's 6 there, 5 times negative 2, and then 4. And then we've got minus 5. This is going to give me plus 5 all over x squared. Obviously, they cancel. This all adds to 0. And you get 0 equals 0. So y is a solution. So the derivatives are, I guess, a little difficult, but after you plug in, it simplifies really easily.
I have a quick question. So when you put the -5 plus 5, is the -5 from the first fraction versus the 6 natural log of x minus 5? I'm confused of where you got that from.
Yeah, there's minus 5 right there that I just circled. And the other one is right here.
Oh, so why do you like reuse it? Because didn't you use it for the -10? Like the 5 times -2. I just don't like.
This 5 would get distributed here.
Oh, so it's a 5 to the 1. Okay, that makes sense. Sorry.
5 times 1, and
My
then
bad.
times -2 log.
Okay, thank you.
Any other questions about that one?
No, I'm glad we did it. Thank you.
What do you mean we did it?
Group effort.
All right, anything else you guys would like to see?
Could we do? I think it's like some with the solid. See if I can find that.
8. Yeah, do surface area of a solid for 8.
Which one? 8?
Yeah.
Okay, A or B?
Oh, let's try B.
I don't know why I just made that space for A. All right, where do I start?
Finding the derivative.
Okay, so how do I do that?
One thing you could do is instead of like, at least this kind of helps me. So you would put 2x minus x squared and make the square root into 1/2. So that's the chain rule, I believe.
Okay, so you bring the 1/2 down in front, right?
Mhm.
You would subtract 1 from the power,
So it'll be negative 1/2.
which just means put it in
Goes
the
down.
denominator.
And besides 1 would be 2x minus x squared.
So that should be the derivative of the inside, right?
That's correct, because we were put the thing down. So that would be, it would be 2 minus x. 2x. There you
Right?
Mhm.
And then everything here is divisible by 2, so they just become 1s. Everybody good with that?
Mm-hmm.
So then let's see, we're doing surface area. So integral 1/2 to 3/2. We need g of x on the outside. And then 1 plus this squared on the inside, right? Of that square root.
Do you need a 2 pi in front of the integral?
I don't know, do I?
I think so.
All right. Let's look in here first. So square this thing out. You're going to get 1 minus 2x plus x squared over 2x minus x squared. You could get a common denominator. By multiplying 1 by 2x minus x squared over 2x minus x squared. And then this stuff all cancels. And left inside, we just have 1 over this. Here's where most people get stuck. They try to start doing u substitutions and stuff like that. But I've got 2 radicals there. So put them together. So basically what I have there is I have square root of a times the square root of 1 over a. What's that going to be?
One.
Right, because if I multiply these 2 things together, then I put them both under a single radical. And you just get square root of 1 or 1. So it looks like you just get 2 pi out of that whole thing.
That worked out pretty nicely.
I'd say so.
Could we do 11b, doing using both methods?
Is that can I do them now, or is it possible to use both methods?
Could you do it now? Sorry.
It's okay. I wasn't sure what exactly you were asking. So let's see. If you divide through by x, then you can get an integrating factor. So if you multiply through, looks like that. That should collapse down to this. Let's see. So 2xy plus x squared y prime. That looks good.
When you divide through by x, shouldn't the 3x become 3?
That's what it was. Integrate. And solve for y. So that, if I make a mistake. So that's integrating factor. If you want to do separation of variables, I think this one's going to work, right? Yeah, this one you can't do because you have y prime minus 3. If it was y minus 3, you could do it. All right, so what I'm saying is if the problem was this to start, you could do it. Because then you could write it that way. And then you could break up the dy dx. You could do that. Does that make sense?
Yeah, just so why did the -2 move over?
I just like to leave any numbers with the x's,
Oh, okay.
the personal preference.
Okay.
Anything else?
Wouldn't it be e to the 2 absolute value of natural log x?
Would what be?
In the mu?
I have that, right? E to the 2 natural log x.
Yes, you have it. And then the e cancels out with the log after you move the 2.
Right.
Like,
Yeah,
will the
okay.
absolute value be needed?
No, this type of problem, it's not a big deal.
So when do we use the absolute value and not the absolute value when integrating 1 over x dx or 2 over x dx?
That's somewhat of a difficult question to answer in that it's kind of an intuitive thing. Like some cases it's very important, other cases it's not important at all. It technically is always the natural log of the absolute value when you integrate. But depending on the problem you're doing, most of the time you can drop the absolute value. That quiz question, that quiz question that I gave you was an example of a time when it was important to keep it, right?
Yeah.
So it's kind of a case by case basis.
Okay. Thank you.
Mm-hmm. Any other questions that you guys have for me?
I had a question about the quiz.
The one that you just turned in?
Yeah, 15.
Okay.
So, do you want to pull it up, or I can just tell you it?
Just go ahead and read the problem if you don't mind.
It is.
Hold on, let's see over here. There we go. That's if it opens.
Yeah.
Okay.
So I started the problem by dividing through by x to get it in the form. So I had y prime minus 2y. Well, yeah, 2 over xy equals x.
Mhm.
Then I took the integrating factor. I did e to the integral 2 over x dx.
You should have that.
There you go. I think that would be my problem. Because then you get,
Because this is plus a negative.
yeah.
It's got to be in the form y prime plus
plus-
b of xy.
Yeah, because when I did my chain rule with my integrated factor times y, it didn't come out right.
Yeah, you didn't get that minus sign.
Yeah, but like I realized it, so like my work's wrong, but I fixed it in my. I was like, that doesn't multiply out correctly, and then I like I couldn't figure out where I went wrong, but when I wrote it back in the equation and multiplied through by the integrating factor, like with the chain rule, I just chain ruled that thing out. I don't know if that makes sense.
I think I'd have to see what you're saying to
Yeah. Yeah, let's see.
really make sense of it.
Yeah, that's why. Okay. Yeah. Because I just had, without that negative there, I just had y times x squared.
Yeah, it would come out as an x squared without the negative here.
Yeah, which then my it didn't chain roll out correctly. All
No.
right, that makes sense. That's all I needed. I just was so confused where I went wrong.
Okay.
Thank you.
So
Mhm.
so what was the final answer for this?
Give me a second.
My work looks like what you have, but I just want to see if I finished it right.
Looks like that, I think. And then of course plug in the numbers, but
So how did you get x cubed there in the above equation, like y dash upon x squared minus 2 upon x cubed?
so you're okay with the integrating factor that I have?
Yeah, but I did not get it. Won't it be only 2 by
Dang.
square?
Sorry, say that again.
Won't it be 2 by x squared instead of x cubed?
Well, I multiply that x squared by everything here, right?
Yeah. Oh, okay.
It's already
Okay.
minus 2 over x, so times another 1 over x squared would be x cubed.
Okay. Yeah, I got it.
And then that works out when I differentiate, right?
Mm.
Because the
Okay.
derivative of x to the negative 2 is going to be negative 2 x to the minus 3, which is that term. It looks like I forgot my y there.
Yeah, so I'm an idiot and I didn't like on the solution side where it's y equals, I put the x squared back under a fraction bar. I didn't put it next to the ln x because I'm dumb.
Excuse me. There's no need to say that.
It's my truth right now.
So what else would you like to see? Anything? Any other questions regarding the test? You can still have your 5x8 note sheet with your formulas. I would very much suggest writing the formulas down. Like surface area, arc length, the equations for volumes of revolution, the form that a diffie-q must be in order to use integrating factor, right? All those things are very important for this test. You'll get the full time on Tuesday. I'll put up I'm going to give you one more quiz today, I think. And I will put up the solutions when you turn that quiz in. So I'm going to make the quiz due for tomorrow morning. And then I will put up all of the rest of the solutions that pertain to all the quizzes and all the content for this test so that you'll have it all. If you have any questions, I have my virtual office hours on Friday, right, and Monday. Anything else?
When were your office hours tomorrow?
They're technically from 9 to 11, I think is what I put them as.
Okay. And I guess I would just like to email you saying, do you want like have a meeting?
Yeah, it'd be nice to know if you're planning to stop in, I guess. That way I'm not just kind of like chilling on Zoom for 2 hours waiting for
Okay.
somebody to join me. So if you have something that you specifically want or time and so forth, just email that to me.
Sounds good.